the next couple of weeks, maybe 3 weeks, but depending on how long it takes, will you please stay where you're sitting? And the reason is because some of you may have noticed that yesterday I picked up your names pretty quickly, but I don't have any idea who about half of you are. I just know where you were. So I identify names first by your location, which means when we get up and start doing stuff today, I won't know who half of you are. I just know where you were sitting by name. And so it just really helps me. The way that my brain works is I'll figure out who you are by where you are first. And then once I get that, then I'll actually see you and recognize your face. And some of you, if you've taken a class with me before, you've probably seen it happen. Like if you, like, I don't think people do it on purpose, but every once in a while there's a little switch, and I'll just cheerfully call you the wrong name if you're sitting where somebody else normally sits. So, and it's not if you don't like where you are right now, you can figure it out. But then maybe starting next week, just pick a spot and stay there. Let's see. I want to talk a little bit about turning stuff in, which you're not going to have to worry about today, and you didn't have to worry about yesterday. But I just want to let you know in advance that the way it's going to work is I'm going to have you turn everything in on Canvas. If there's something that is handwritten, whether it's like something that I give you that you write on, or whether it's something that you just like are writing down on a sheet of paper, then in addition to submitting a picture on Canvas, I want it on paper as well. And I'll explain that in more detail later, but just know everything gets turned in on Canvas. If there's any handwritten component to your work, that gets turned in on paper as well. Okay, I'm going to take roll again real quick, because that wasn't real roll. Now it is Eli. I don't see you. Okay, Cooper is here, Meg is here, Joseph is here, Ava is here, Mirari is here, Amelia is here, Laura is here, Mason, Mel. You are you Alexander?
Yeah.
Okay, you're here. Emily is here, Olivia is here, Hunter is here, Andrew is here, Kaysen is here, Thea is here, Mathis is here, Allison is here, Jacob, Victor, Jordan, Dawson, Gabe is here, Reed, and Aiden is there, yeah. Matthias is here, Abel, Carlos, Lillian, Celeste, there, and Tristan. All right, great. So, so here's our plan for today. First of all, if you haven't had one of my classes before, you should know that every day I will post what we're doing on Canvas. It'll kind of be the same sort of structure for the most part. And I organize things by week and then by day. So what you're going to see is something like this. And just for those of you who get confused about stuff, I have a way of doing things that I think will work really well for everybody, but just understand the current week is always going to be at the top. And then every other week will be below that in order. So if by the time it's like week 14 of the semester, it'll say week 14 and then week 1, week 2, week 3, week 4, week 5. So that way you don't have to scroll all over the place. And then within the week, you'll see the days, since physics meets both on odd and even days. On our long days, not all days, but on our odd days, you'll see 2 dates listed, only one of which is going to apply to you. And then when you click on the module itself, it'll pull up an agenda. And if we don't get through all of this, then I could sometimes scoot things to the next day. So sometimes we'll get to the end and be like, oh, we didn't get there, and so just know I'll fix it later. But this will give you an idea of what we're doing. So if you ever want to know, hey, what are we doing? Here it's going to be. And a couple of things to think about. One is, if you're a person who normally likes to just go right to assignments so that you do the work and get it turned in, that doesn't work so well in this class because everything else shows up here. And if it's not an assignment, you may not know what to do for the assignment if you haven't looked at the notes or watched the video or looked at the agenda so that you have some idea of what's going on. So just be aware, the best starting point for this class is the modules. If you target just doing the assignments, then a lot of times what you'll do is you'll come to me and you'll be like, how do I do this? And I'm gonna say, go to the module, okay? Because that's where all the information is. Some of you also may have noticed that I have a video camera set up. I record virtually all of the lessons that we do. That way people who are absent, or if you need a little bit of reinforcement, you'll be able to go back and see that. So you'll be able to see if I'm explaining something or giving a demonstration or giving some sort of a presentation, you'll see all that stuff. And I shut the video camera off when it's labs because that would just be too crazy. But usually what ends up happening is during a lab, there'll be several times where we pause and everybody gathers and I'll explain something to you and the recorder will come back on then. So you'll always be able to see the stuff that you really need to see, even if you were absent. Let's see what else is on my agenda. You all did a great job yesterday of keeping the room clean. I really appreciate it. I'm going to try to do my part of keeping the room clean, and I'm going to ask that you do the same thing as well. The big thing is if you use any equipment, put it back where you found it. If you take it off a shelf, put it back on the shelf in the exact same way, even if you weren't the last one to use it. Because if you go to the shelf and you take like a book down and you put it on the table and then somebody else uses the book, they don't know where it goes. So it's just gonna stay on the table. So if you get it, you put it back. And I'm gonna try to do the same thing so that ideally this will be a space where we can actually get some work done on a reasonably effective day-to-day basis. Okay, yesterday I chatted with you a little bit about my goals for you, and really what it boils down to is I know that everybody here is going to be like more than capable. You take one of these and pass it on. Grab one of these and pass it on. I know everybody's going to be more than capable of doing the things that I am looking for. What I'm hoping is that we create a culture in this classroom where everybody is interested in what's going on and having fun learning the things that we do. And so what that means is that it's sort of a culture of curiosity. So if you think about it, real science and real scientists are always engaged in trying to figure things out. It's super fun. If we do that, it will almost certainly be really fun for all of us. That's my big goal for all of you. But I also want to know about you. So you can take longer on this if you want, but what I would like is for everybody to take a minimum of like 3 minutes. And I want you to just tell me a few things. One, make sure your name and your grade are on the card. Nobody's gonna see this but me and Ms. Jackson, but so you don't have to worry, like I'm not gonna give it to administrators or parents or other students or anything. But I wanna know who you are because I want to make this something that I know about you personally. And then this sounds, why are you taking this class? I really want to know. It sounds like the kind of thing that people ask as a perfunctory question, but that's not what this is. I really want to know. I want you to be honest. I want you to be specific and detailed. If you are here because you absolutely love the idea of learning about physics and how stuff works, then really put that. If you have no interest in physics at all, don't put that. It's okay. I'm not going to use this to condemn you or judge you or make your life more difficult. I really want to know why you're here. If the truth is you're here because your counselor told you you got to take a class, it better be physics, and you're just going to try to get through, I'm okay with that. I really am. I just want to know so that I can help you target your own goals. So be as honest as possible. And if you absolutely you're not feeling really positive about what's going on, either in this class or in general, if you're comfortable, you can tell me that too. And again, I'm not going to use that to come after you. What I would like to do is use that to maybe help you. If there's anything I can do to help you feel better about whatever is going on, I would really like to do that. And then anything else you want me to know. And this is stuff, so I'm not asking to dig into your personal life, but if there's something that you want me to know that will allow me to interact with you in the way that you want, that would be terrific. So feel free to share anything that you're comfortable sharing. So just take a few minutes and do that, and I'm going to chat about some other things while you do that. But I want to make sure that I get this information. And then let's see. I already talked about turning in work. Just understand. We'll probably launch. The first turn in is probably going to be Tuesday of next week. So be ready. For both of those things to happen, for a picture to be turned in and handwritten work on paper to be turned in, because that's what we're going to be doing today. And it is largely logistical. So I am asking you to jump through a hoop here, but ultimately it's going to benefit you. There's logistical reasons that I will explain later. So I'm not trying to make your lives more difficult. All right, I want to go through just a couple of things. So we're going to go through the relevant information on the syllabus, but I'm going to break it up because I know it gets a little bit dull. It actually is pretty important. Most of the stuff that I have to say is going to apply to at least some of you, and it's going to be something that at least some of you really need to know and think about. It's not all going to apply to everyone, but some of it is going to benefit you. So we'll break it up. I'm going to keep it short. The videos will be posted, so you'll be able to look back on this information if there's anything that you need to refresh. There is a presentation that I will post to Canvas. It's not posted yet, but I will post it once I've gone through everything. And after we've gone through everything, the syllabus will be handed out, and you will need to sign that, get a parent or guardian to sign it, and bring it back to me. And it's all wrapped up into the same, it's different versions of the same information. So it's not like there's a syllabus and then this presentation that are different. It's all the same stuff. So what I want to talk about first is just our general responsibilities. So so as I said, this isn't going to apply to everybody. For some of you, your target grade is an A or a B, and it always has been, and that's great. I support that. For some of you, it's likely that you sometimes need to navigate just earning credit. So what I want to tell you is the key to earning credit in this class, getting at least a C, which is a passing grade. Come to class, be here as often as you can, and be on time. Use your class time productively. So while you're here, you should be working on and thinking about physics virtually all class period. And then turn in the stuff that you do, and turn it in on time. If you do those three things, you'll get a C. The class is built so that anyone who does these three things is gonna get a C. It's that simple. If you want a B or an A, that's fantastic. I'll talk about those things later. I'm not gonna talk about those now. But for anybody here who, if passing the class is your goal, this is how you do it. It's pretty straightforward. The way that we're gonna run things in the classroom, this is a big class. There's a lot of people here. And so what I want to make sure is that everybody understands that you really have, it's like you have a job. Now, I know you didn't apply for it. Some of you didn't want it, but it really is similar to having a job. And so here are the things that I'm going to expect from you on a daily basis. The first thing is you're going to use the time that we have in class to work on the things that I'm giving you to work on. So I don't want you to work on stuff for other classes. I don't want you to just socialize. There'll be lots of times when we're transitioning and you can chat, and I like to have a relatively relaxed feel to the classroom, but it has to also feel productive. So you're going to be, you need to be working, and that includes times when it is more than appropriate for you to be chatting. So for example, one of the things you're going to do today is set up those motion sensors. You don't have to talk about the motion sensors while you're doing that. You probably won't have to like communicate with each other about how to do it, because it's pretty straightforward. But what I want is to see you doing this. Oh, hey, well, so are you going to go to the game tomorrow night? Oh, yeah? Well, me too, except I probably won't be able to get there on time. See how I'm putting this together and talking at the same time? That's what it means to be productive and social. Where it starts to fall apart is when it looks like this. Oh, are you going to go to the game? Okay, yeah. Well, I can pick you up if you want. Sure. Because then you're holding stuff, but you're not doing anything with it. So just be aware that my expectation is you're using the class time that we have. Have integrity. What this means is that what you say you did is what you actually did. And we'll talk more about this with specific assignments, but for example, the work that we're going to be doing today, there's going to be some documentation. And there's a couple different ways that you could do the documentation. One is you can participate in the work, talk with your partners, you can make drawings of the things that you see on the computer screen, you can write down your thoughts from the conversation. That is a way of doing the work with integrity. Another way you could do it is you could look at somebody else's paper and just write down whatever they have while you do something else. That lacks integrity. So that's gonna get you into problems with your grade and otherwise. So make sure that if you give me something, it reflects the things that you did, that you know, and that you're able to do. I want you to be engaged in class, so this is not just something where it's like, it'd be nice. It's your job. You have to. You have to do it for yourself. You also have to do it for the other people in the class, and you have to do it for me too. We have to be a team, and part of that teamwork means we're all locked in to making sure that people are actually thinking about physics and learning stuff. Collaboration. This one can be challenging for people like me who struggle with things like social anxiety, people who are introverted. Those are characteristics that I have. So if it were up to me, I would be alone a lot. And that would be really more comfortable. And some of you are like that as well. But realistically, given the constraints of both our society and of the school and of this particular class with 30 plus people in it, we're gonna have to collaborate. So you have to be able to work with other people productively. If there's something that I can do to help you with that, let me know. I know there might be people that you want to avoid, or there may be people that you really would like to work with. I can help you do that. I can help you navigate the stuff, but it's not really going to work for you to say, can I work by myself? It almost never is going to work out for you to be able to do that. And then if I ask you to do something, you got to make sure you do it. And this is not going to be the kind of thing where it's like, I say Joseph, can you pick up your pencil? You didn't do it, go to the office. You moved too slow, you're out. It's not going to be something like that. But there are times when you and I might have a different idea of how best to get something done. And I want to know your opinion. If you tell me I work better in the library, or I work better when I'm listening to music, or I want to work on my math now because I'll do this better at home, I appreciate knowing that. But it's my call. So just be aware that if you pull out your math and you start working on your math and I say, hey, you should be working on the assignment, that means put your math away and get to work on the assignment. Because in this class, you're going to do physics, not the other stuff that you might have going on. All right? And then, so you all have a job. It's not a paid job, for better or for worse. It's not necessarily something that you signed up for, but the reality is these are your job-related responsibilities. I have a job too. Mine is a little bit more formal than yours. The first and most important job I have is to make sure that everybody here can learn and that it feels good. And so there may be times when I have to ask you to do something or to not do something because of the way that it affects other people. I, like many of you, I like to work with music. I'll turn music on, like I sing and like I crank it. I'm a complete dork. Like I'm an embarrassment when it comes to like doing stuff. But I don't do that here during class time because I think it would be distracting for a bunch of people. And you may work best in a certain way, but if that ends up making things difficult for other people, then we may have to have you work a different way. It's my job to make sure that things function and go really smoothly in here for everyone. Part of my job is to simply facilitate your learning. That means I provide things for you to do. I ask you questions. I will answer if you have questions. If you want to understand something, I want to talk about it. If there's something you don't get, if there's something that you just want to chat with me about, I'm all in. But that's part of my job, and it's the best part of my job, quite frankly. If you need clarification, how do I do this? When is this due? What do you mean by this question? What does this word mean? That's my job, and I will help you. Sometimes people get kind of picky about tests and stuff, but I tend to be pretty understanding. Like if there's something that I can do that can help you clarify for me what you know and what you're able to do, I'll provide the information. So when we have a test, if you have a question, I want you to ask it. And then the last really important, I have way more than this, but these are the things that I think are really relevant to you. The last thing is, it's my job to make sure you know how to get points and have those points accrue to whatever grade you're targeting. And I want to be really clear about this because while it's my job to make it clear to you how you're going to earn points, it's not my job to get you more points if you didn't do those things. And we'll talk more about that later because if I make a mistake, of course I'll correct it. Like if you take a test and I add up your score wrong and I give you a 32 out of 40 when you actually got a 37 out of 40, that's on me and I'll fix it. But if you come to me and you say, how can I get more points in the class? I'm going to say, you do the stuff that I've been telling you. And we can talk more about this later. Your grades are really important to you. That makes them really important to me. But fundamentally, it's your job. So if there's an issue with points, I'm going to put that on you. I'll tell you how to do it, and then you do the work. So if grades are really important to you, just be aware it's going to be you that has to earn it. Okay, and that is all we need to talk about in terms of syllabus type stuff for now. Next week, we will talk about the different categories, formative and summative and stuff like that, and then we'll chat about late work and some special circumstances and things like that. So does anyone have any questions about any of that information? Okay. All right, let's step away from nuts and bolts and let's come back to motion sensor. So yesterday when we left off, I was kind of pushing you to figure out some stuff. And the reality is that you did a fantastic job of just thinking and trying to figure things out. And it's kind of, I hope that you found it fun and maybe even a little bit challenging. But what I'm going to do now is I'm going to just tell you some stuff because I already know a bunch of information about this motion sensor. And I think at this point, it'll be more efficient, more expedient for us to just start using it as intended. So I'm going to tell you some stuff and I'm going to show you some stuff. The first thing is that the way what this thing actually does is it measures time. That's the only thing it really measures. This device, and we talked about this yesterday, some of us talked about it, I don't remember if I talked about it with you or with the other class, but the way this device works, this thing right here is a speaker, and it's also a microphone. And what it does is it uses the speaker to make a little click, and then it uses the microphone to measure how long it takes for it to detect a click. And depending on how long it takes to detect the click, it can figure out how far away the click was when it hit something and bounced back to the microphone. This is an electronic bat. This uses sonar to figure out where things are. And if you've never used sonar before, it's actually really easy. I'm not going to have you do it right now, but in a few minutes after I've told you some stuff, what I want you to do is I want you to find a nice, safe spot. Outside is probably best, but you could do it, like, there's places in the classroom where you could do it. And what I mean by a safe spot is a spot where you can walk straight toward a wall, knowing that there's nothing that you're going to trip over. There's nothing below, like, waist level. So, like, right here toward this wall would be great. And what you can do is close your eyes, and as long as it's reasonably quiet, you can't do it if there's like a bunch of noise, but if it's reasonably quiet, and you close your eyes and you walk toward the wall, and you talk, you make some noise, you can hear. I can hear the wall reflecting back. You won't run into it, because you can hear your own. We can echolocate. We do it all the time, we just don't do it consciously, because most of us use visual cues rather than sonar. But this doesn't see, it only hears. It hears it hears little clicks, and it's able to measure the time that it takes for a click that it emitted to bounce off something and return to the sensor. And the speed of sound in air is always about the same, it turns out. We're just lucky that way. It's not exactly the same everywhere, it's not exactly the same every day, but it's so close to the same that that this can just use one number for the speed of sound. And if it knows how long it took for the sound to return, and it knows the speed of sound, then it can figure out how far away something is. Distance is equal to speed times time. Speed is equal to distance over time. So it still does a little algebra, right? The computer does the algebra part. This just measures time, and that's it. If you know how far away something is at one time, and then you make another measurement of its position at another time, and another measurement of its position at another time, and you know how long it took for that thing to move those distances, then you can actually find out how fast it's going as well. And there's even more that this can tell us. We'll look at it later. But basically what it boils down to is by using time to determine distance, and then using time with distance to determine velocity, this thing can tell us how fast something is going, it can tell us how far something is going. It can even tell us if something is speeding up or slowing down. Now there's a couple of things that are weird about it. One is, because it's sonar, it doesn't actually know what it's looking at. It makes a click, and measures how long it takes that click to come back. That's why yesterday, when I walked in front of it, it thought I was going 30 meters a second, because it was measuring the distance to the whiteboard over here, which was about a meter away, and then it measured the distance to me, which is about like a third of a meter away, and then it measured the distance to the whiteboard again. It doesn't know what's actually going on. It dutifully did the calculations for something that started here, moved here almost instantly, and then moved back almost instantly. Because that's the only thing it can do with the information that it has.
The velocity's fast.
Yeah, it looks like a really fast velocity, but it's not, right? So what that means is, in order to get useful information from the sensor, we have to provide it with a reflective surface. A notebook or a clipboard or a book or something works really well. And we have to hold this in front of that speaker microphone thing and move it around in such a way that it doesn't accidentally pick anything else up. It also works better if you put it at least close to, if not at the edge of a table or a bench, because if you put it over here, the sound can reflect back off of the table. It gets some weird interference. You'll know after a few practice rounds if you're getting good data, because what you'll see will make sense. So let me show you what I'm talking about. I'm gonna get this set up. And then I need, Amelia, is that right? No, Allison. Can you, when I say go, just use that mouse to click on the collect button? Okay. All right. I'm gonna say 3, 2, 1, go. Ready? 3, 2, 1, go. All right. So that is, it's kind of interesting, right? Because you look at this and it's like, there's something about it aesthetically that jumps out and says, oh, that's meaningful data. How many of you just got these like lines yesterday? Like, it's just like, that's garbage. That wasn't actually anything that gave you real information. Here's a trick. If you click on this little button right here, this magnifying glass, it'll zoom in and give you as much data with the biggest scale possible. You can do that with both this position and this velocity graph. So let's look at what these graphs are telling us. It looks like when Allison clicked go, that I was about 0.7, this is 0.7 meters away from the sensor. And then I must have walked backwards, because I went from 0.7 to like 1.2 meters away. So I started here, and I walked over to here. And then I walked back toward it, and I ended up a little bit closer than I started. I ended up almost like a half a meter away. These sensors don't work real well really close. So if you try to measure things that are like more than, closer than like 10 centimeters, it just won't work. And it won't work as you get really far away either. So, but anywhere in between like a half a meter and 2 meters, it works pretty well, especially if you use a sturdy reflective surface. Now let's look at this velocity, because there's two things to think about here, and we'll talk about, I'll tell you the first one, we'll talk about it more later, but there's a part where it's up in positive velocities and a part where it's down in negative velocities. And negative velocities seem weird, but actually these are just directions. Positive is away from the sensor, negative is toward the sensor. So here, I'm walking away from the sensor, and here, I'm walking toward the sensor. We'll talk more about how to interpret these velocity graphs. But for now, let's just look at the fastest I was going and see if that kind of matches up with what we saw. This is about 0.5. That's the fastest I was going in the positive direction, so that's away. And the units are meters per second. 0.5 meters per second. This is a meter. So a half a meter is like this far. And a second is like this. So a half a meter per second would be something like this. Does this look like about the speed that I was walking? Yeah. Pretty good, huh? These things work really well if you get them set up right and you can avoid interference. Interference is going to be the big problem with us today, because there's so many of you and this classroom is so small and crowded. These things can't tell the difference between their clicks and the clicks of another sensor. So you might find that you're doing everything right, but somebody else's sensor is kind of aimed at it and they get all confused by that. That really blows their little tiny electronic brains. You might find that you don't have enough room in here to do what you need to do. You may find that even the noise from people in the room, if this is it's a piece of audio equipment. If it gets really loud in here, it's not going to work well. So what I'm going to say is find a spot where you can work without losing your focus and without distracting other people, and somewhere reasonably close. So some of you might go outside, or you could go, if the cafeteria is open, if it's not too crowded, you could try the cafeteria. I think there's a couple science teachers that have prep. I think Mrs. T has prep, so if you're one of Mrs. T's favorite students, which is just about everybody, she might let you work in her room. You just make sure that you aren't annoying whoever you're with. And your goal for today is gonna be to work through this activity. It's not due today, so you're just gonna start the process. We're gonna talk about it several times. So you'll do some work, and then we'll stop. We'll talk about what you've discovered, and then you'll do some more work, and we'll stop, and we'll talk about what you've discovered. The assignment itself is here, and there's a lot of stuff. There's a lot of instructions, and there's a lot of information, and basically, there's two things you can think about. Number one, and the most important thing is, are you engaged in learning? Because if you're engaged in learning, then that's what's most important. It's possible that some of you may miss this instruction right here. Sketch what the X versus T graph looks like on your computer. If you don't see that, maybe you don't make the sketch. But I don't want you to worry about like, oh, am I gonna lose points for that? What I want you to ask yourself is, am I trying to figure this stuff out? Am I actually trying to learn? And then the second thing is, are you providing me evidence with what you, of what you did? Those are the two key things. I am super flexible about like, oh shoot, it says X versus T, but I drew the V versus T. I don't care. Like, what I want is for you to launch into this work, learn, have fun, and play around, and investigate, and challenge yourself. If you're doing those things, you're gonna be just fine, even if you miss a dotted I or a crossed T. What you're gonna be doing with this activity is matching up two things. One is your actual motion. So like, you all could tell me what it looks like when I move. Like, am I moving fast or slow right now? Pretty slow. How about, am I moving far or am I moving short? Short, right? How far away am I from the sensor? About. Okay, now how far away? All right, so you see, like, you can describe my motion. The thing is, we can talk about motion with words, or we can describe motion with images. I can tell you all those same descriptions with this graph. Like, I can tell you that here I'm moving really slowly, here I'm moving faster, here I'm moving slowly again. Here I'm moving toward the sensor, here I'm moving away from the sensor. Here I'm about 0.7 meters from the sensor, here I'm about 1.2 meters from the sensor. I can tell you the same information from these graphs that you were just able to determine by watching me. Your goal for the next couple of days is going to be to lock those two things together in your brain. You want to be able to read these graphs the same way that you can look at something moving. It's the same thing. It's depicted two different ways. The nice thing about the graphs, they're there after the movement has ended. If you want to know how fast something was going 10 minutes ago, you can't watch it again. But you can look at a graph made by a motion sensor. The position graphs, easier to understand. The velocity graphs get complicated because of the way that our brains want us to interpret this stuff. And so that'll take, the velocity graphs will take more practice. But many of you are going to find there's some trickiness with the position graphs as well. When the assignment talks about X versus T and V versus T, the X is for position, the V is for velocity, and the T is for time. So this top graph is an X versus T graph, position versus time. This bottom graph is a V versus T graph, velocity versus time.
Is there more chairs like that?
No, but you know what? We're just about to start moving around, so you won't need one. Yeah, I mean, if you need a break, you can take one. We'll find your chair. You can take one then. All right.
Just go get it from the other room in case you need one.
Yeah. Let's see. So I'm gonna pause here for a second. And first of all, does anybody have any questions about what I'm gonna ask you to do momentarily? Yeah.
What are the group sizes?
So the group sizes are going to be determined by the equipment. My guess is that most of you will be in groups of 3 and a couple of you will be able to be in groups of 2. The way and somebody can use this stuff, I won't need this. The way it'll work best is if you just like, if you can't find equipment that works, go find a group. no bigger than 3. Okay, other questions? Yeah.
Can we print out the worksheet, or do you have this?
So I don't print stuff out. If you want, we can talk about it separately. In general, I don't print stuff out because it's all on Canvas. Yeah. You don't. You sketch it on paper. You're going to be writing with a pencil on paper, like the good old days, the great old days. Other questions? Okay. So before you get started, if you want to take a quick break, now's a great time. Just remember, no phones, and just be quiet as you're moving around in the hallways and stuff.